Alright, everybody's losing their mind over AI right now. AI images, AI videos, AI tools, AI this, AI that. At this point, it's probably one update away from stealing my coffee machine. But most of it looks flashy for 5 seconds. Then falls apart the moment you need something actually usable. So today we are putting that to the test. I'm taking a clay photo reference, feeding it into Nano Banana 2, and we are gonna see if this thing can generate something actually worth a damn. Because making something looks okay is easy. Making it look good, that's a different story. Welcome back to Primal VFX, I'm your host Skart, and if you want to see more cool shit like that, smash that like button, subscribe for more awesomeness, and let's dive in right now!
Okay, so the first thing we need is a good photo reference of our clay material. Because if the reference sucks, the result will suck too. Then we're going to use ChatGPT to create our prompt for Nano Banana 2. So here's my photo reference. Let's just drag and drop it straight into ChatGPT. And now we're going to ask ChatGPT to generate a prompt for Nano Banana 2 that recreates the PBR material from this image. This is a clay material, so we need the usual suspects: albedo, roughness, normal, and displacement. Alright, press enter. And now let's see what ChatGPT is cooking. After just a few seconds, it spits out the prompt ready to be copy-pasted into our AI generation tool. And as you can see, it's actually pretty detailed. It describes the surface, the texture, the lighting information, and all the little characteristics of the clay. Basically, it translates our reference image into something the AI model can properly understand. So now let's just copy the whole prompt. And we are going to switch to our image generation model. For this test, I'm using Higgsfield.ai, which gives us access to Nano Banana 2. Alright, let's paste our prompt in here. And we're also going to drag and drop our photo reference again, just to give the model even more context. Before, we used to work with Nano Banana Pro, but now there's a new option, the freshly released Nano Banana 2. So obviously, we're going to use that. Let's set the image ratio to square, choose 4K quality, and click Generate. Now we just wait a bit and see what the AI gives us. Alright, so after about a minute of generation, here we go, let's take a look. And honestly, this already looks pretty fantastic. We've got our albedo, roughness, normal, and displacement. Everything is packed inside a single image, arranged into 4 tiles. So right away, this is actually looking very convincing. So to get proper 4K maps for each channel, we need to upscale the image. Let's click Upscale, choose 2 times and leave the sharpness and denoise settings at their default values. And click Upscale. Now we wait a little bit again, and after a few minutes, boom! Now we've got exactly what we wanted. An 8K image with 4 clean texture maps ready to go. Let's download these maps. But don't get too excited yet, this is just the starting point. If we want something production ready, we need to fix them up. So next, a little map surgery. And that's where things start to get spicy. Alright, now we're in Photoshop. And the first thing we need to do is load our generated map. Right now, all the textures are packed into a single image, so the first step is to separate them and save each map individually. So let's start with the albedo. Just crop the first tile, save it and name it simply albedo.png. Nice and clean. Now let's move to the roughness map. Same thing. Crop the tile, save it and call it roughness.png. Next up, the normal map. Crop it, save it and name it normal.png. And finally, the displacement map. Crop the last tile, save it and call it displacement.png. Alright, perfect. Now that all our maps are separated and saved, let's jump over to Substance Designer. Let's create a new graph. Choose the metallic roughness template and make sure the output resolution is set to 4K. Then click OK. Substance Designer will open a fresh graph ready for our material. Now let's drag and drop the 4 maps we just created into the graph. And boom, there they are. First thing we are going to do is organize everything properly. Let's connect the albedo map to the base color input. Alright, already looking pretty nice. Before going further, let's make sure our material has tessellation and displacement enabled. Then go to Material, then Edit, and set the tiling size to 2. Now if we look closely at the albedo map, we can see something. The texture doesn't tile perfectly. If we apply this on a large surface, we'll start seeing ugly seams and repetition, so we need to fix that. To do that, let's create a node called Make It Tile Photo Color. Now connect the bitmap into this node and the output of that node into the base color. And just like that, the texture now tiles properly. Pretty nice. Now we can simply duplicate this node and apply the same process to all the other maps, so everything tiles consistently. Let's start with the roughness map. Duplicate the tiling node, plug the bitmap into it, and then add a grayscale conversion node. Then connect the output of that grayscale node to the roughness input. Perfect. Now let's do the same thing for the normal map. Duplicate the tiling node again, connect the bitmap, and after that we'll add a normalized node just to make sure the normal data is perfectly clean. And as you can see, the result is already looking pretty solid. Now let's move on to the displacement map. Same workflow. Create another Make It Tile Photo Color node. Connect the bitmap, and now the texture tiles correctly. Then we'll add a grayscale conversion node and connect that to the height input. Nice. Now let's isolate the displacement map for a moment so we can adjust it more precisely. We'll temporarily disconnect the base color, roughness, and normal just to focus on the height. Let's add the roughness back quickly so we still have something visible in the preview. Now we'll insert a levels node between the grayscale conversion and the height input. This allows us to remap the values of the displacement if we need to push or reduce the height later. Now let's increase the tessellation factor of the material and switch the renderer to iRay to properly preview the displacement. Alright, now we're getting something. Right now the mesh quality looks a bit rough, because there isn't a lot of subdivision on this preview object. But that's totally fine, this is just a preview. Now let's add a clamp grayscale node just before the height input. This ensures the values never go too low or too high, which helps keep the displacement stable. Alright, now we can reconnect everything. Base color, roughness, normal, all plugged back in. Let's switch the renderer back to iRay one more time just to double check everything. And yeah, this is actually looking pretty neat. We've got a clean result, good surface breakup, and everything is tiling properly. We can also switch the preview object in the scene to test the material on different shapes. Sometimes a material looks good on a cube, but behaves very differently on another mesh, so it's always good to check. Alright, now it's time to save the project and export the maps. Right-click on the substance graph and choose Export Outputs as bitmaps. We'll deselect the maps we don't need. Set the file format to EXR and click Export Outputs. Alright, maps are ready. But textures alone don't mean much. Now it's time for look dev. And trust me, Thanos is about to get juiced. Alright, now we've got our 4 textures ready to go. We've got the albedo, roughness, normal map, and our displacement map. Now over here in Maya, I've got a really nice model ready for the test. A pretty badass one actually. It's Thanos snapping his fingers. Basically the final countdown for humanity. The pose looks powerful, the sculpt is super clean, and the model has a lot of really nice details. You can clearly see all the surface information in the skin, the folds, the wrinkles. It's a very solid piece of geometry, perfect for testing a material like this. Now I've already prepared a basic look dev scene. We've got an HDR eye, a top light, a left key light, and a rim light to give us that nice dramatic separation. I also added a small light in the background just to soften the backdrop and give the whole thing a bit more depth. Our camera is already set up as well. It's a low angle shot with a 50mm focal length, which makes Thanos look even more imposing. If we quickly check the outliner, everything is clean and organized. Exactly how we like it. And remember, this is actually pretty important. If you're working in a pipeline or inside a studio environment, having a clean scene structure makes everyone's life easier. Your teammates will definitely thank you for that. Alright, now it's time to create our shader. Let's create an AI standard surface material. Rename it Clay, and don't forget to rename the shader engine as well. Now select the model and apply the material. For the base color, let's start with a neutral gray, something around 0.14, and we'll set the roughnesses to about 0.35. Now let's launch the IPR render and see what we've got. Alright, the scene already looks pretty nice. The lighting is dramatic, the shapes read well, and the sculpt detail is clearly visible. Now let's bring in our textures. Just drag and drop the maps into the hypershade, and let's organize everything properly. First thing to check, color spaces. The base color should stay in sRGB, but for the roughness, normal and displacement, we need to switch them to raw. Now here's the thing. This model doesn't have proper UVs for our clay texture. So instead of fighting with UVs, we're going to use an AI triplanar node. Let's start with the normal map. Connect the file node output into the AI triplanar input. Then create an AI normal map node. Connect the output of the AI triplanar into the AI normal map. And finally plug the output into the normal camera of the material. Now let's refresh the render. And as you can see, the texture scale is way too small. So let's fix that. Inside the AI triplanar, reduce the scale. Let's try something like 0.1. Still too small. Let's push it further down to 0.02 on all axes. And yeah, now that looks much better. The texture scale feels much more natural. Alright, now we just repeat the same setup for the other maps. Create another AI triplanar for each texture, connect the nodes properly, and apply the same scale so everything stays consistent. For the base color, we are going to add an AI color correct node. This will allow us to tweak the color values if needed. For the roughness, let's insert an AI range node so we can remap the roughness values later. Then connect the red channel to the specular roughness input of the material. Now for the displacement. Open the shader graph of the material and drag the AI triplanar node of the displacement map into the displacement slot of the shader engine. Maya will automatically create a displacement shader node. Let's also add an AI clamp node to keep the displacement values under control. Now refresh the render. And boom! We already have a really interesting result. The clay surface reads nicely, the breakup looks natural, and the displacement is doing a lot of heavy lifting. Now let's clean things up a little bit and rename our nodes properly. Again, clean scenes are happy scenes. Alright, now let's start tweaking the material. First, the base color. Inside the color correct node, let's increase the gamma to 1.2. Yeah, that already looks a bit better. Now let's tweak the roughness. Inside the AI range node, let's adjust the values. Set the output max to 0.5. Actually, that's a bit too much. Let's push it to 0.9 instead. And increase the contrast to about 1.2. Nice. That gives us a more interesting surface response. Now let's lower the displacement height slightly. Something like 0.5 works pretty well. Let's refresh the render. Yeah, that's looking solid. Now we can push the material a bit further. Let's tweak the specular IOR. Set it to 1.35. And we can also add a bit of subsurface scattering, which works really nicely for clay-like materials. Set the weight to 1. Change the color to a slightly brownish tone. Now switch the subsurface type to random walk V2. Let's adjust the radius values a little bit and darken the color slightly. Actually, the effect is a bit strong. So let's lower the weight to about 0.5. Much better. Yeah, this is looking pretty nice. I'm really digging what we've got here. The surface feels rich, the lighting works well, and the material reacts nicely across the model. And after rendering it out with a little bit of compositing magic, here's the final result. So what do you think, guys? Honestly, this is a pretty cool way to generate clay materials extremely fast, especially with the help of Nano Banana 2 and a bit of AI magic. Which honestly makes us wonder how far this kind of AI-assisted material creation can actually go.
Thank you so much for watching. If you enjoyed the content, you know what to do. Subscribe to my channel for more awesomeness. And I see you guys in the next video.